Okay, well, welcome back to some problem solving. We're going to do a couple basic problems that a lot of teachers would assign something very similar to this. So we're going to look at a consecutive integers problem. We get those a lot as a way to understand the making of a verbal model. That, if you've understood anything about the last lesson, is I really want you to get the verbal model idea. I want you to know how to make a verbal model because that really helps you break down a word problem that's difficult into an equation, a linear equation that you can solve pretty easily. So we're going to look at that with the sum of three consecutive integers. And then we're going to go ahead we're going to do a real live word problem in just a moment. So, what we got out of it, read a problem carefully for sure. Draw a picture if you can, or find a formula if you can. No matter what, though, make a verbal model. Assign one variable and then solve it. So, let's read this problem carefully. The sum of three consecutive numbers is negative 123. Find the numbers, or integers, if you will. That's what we're talking about here. I'm going to read it two times. And what I'm trying to do, I'm not trying to solve the problem. I'm not even trying to think of an equation. Honestly, all I'm doing is getting the idea of what's going on. I'm looking for some words that mean math, so some math words. I'm looking for the word that means equals. That's a big deal because what we learned in the last lesson, last video, is that all the stuff, all the expression before the word that means equals goes on the left, and all the stuff, all the words that go after the word that means equals goes on the right-hand side of that equation. So I'm looking at the word sum, the sum. So I know right now I'm adding. That's a big deal. In fact, as the last lesson, you can underline that and put a plus. The sum of three, so how many numbers? Okay, we're dealing with three consecutive numbers. I'm adding three numbers. The word consecutive, we're going to have to deal with that in a bit. So the sum of three consecutive numbers. I know I'm adding. I know I have three numbers. I'm going to have to deal with consecutive is negative 123. Okay, so sum, I'm adding. What am I adding? I'm adding three numbers. Consecutive, we'll have to deal with that. Is, I know that means equals. Here's how a verbal model looks. This is not a verbal model right now because we're going to have to kind of translate this. When we talk about a verbal model, we are literally just putting the math ideas on a page. We're going to use some of our stuff. So like the word sum means plus. We're going to throw some pluses in there. The word is means equals. We're going to throw an equal sign in there. But we're not really putting variables in there yet. That comes the next step after your verbal model. So a verbal model can look something like this. It says verbal model, well, that would say the sum of three consecutive numbers. Sum means adding up. How many numbers am I adding? Three of them. So a verbal model would be something like, you get your first number, you get your second number, you get your third number, you are adding them, and that is, or that equals, negative 123. That would be like a verbal model. All it tells you is practically what you're doing. You're adding, that's the sum. You have three numbers, first one, second one, third one, and they have to equal negative 123. Now is the idea that we start assigning variables. The key thing about assigning variables in this particular problem is that word consecutive. So yes, we have three numbers. Yes, we're adding them, and yes, they got to equal negative 123. But the word consecutive tells you how those numbers relate to one another. So we're going to assign a variable, but keep in mind, you have to assign one variable. You can't put x, y, and z here, at least not in linear equations. With linear equations, you have to have one variable raised to the first power. So the word consecutive, something takes a little thought. Consecutive means, well, like the days of the week. They're one right after another. So Monday and Tuesday are consecutive days of the week. Monday, Tuesday, Wednesday would be three consecutive days of the week. That's the idea. We're looking for three consecutive numbers. A big hint here is call the first number x or y or z or any whatever you want, but call the first number a variable. Now, because we have to relate everything back to that one variable, the second number and the third number have to involve x. They can't be a different variable. why don't you think for a while? If you got to pause the video after I ask you this, do it. That's okay. But I want you to think about how consecutive numbers work. How do you get from 4 to 5? Consecutive numbers. How do you get from 27 to 28? What are they separated by? How would you go from any number to the next number? Well, it's not a multiplication concept in general. How would you go from 11 to 12, or 14 to 15, or 1 to 2, or 7 to 8? Whatever you say, it's got to work for everything. How do you go from 4 to 5? Well, it's an addition concept. Let's try that. Let's try to make this work for all numbers. So what I mean by that is you'd have to put any number that I tell you here, and using the formula you make up here, you'd have to get the next number. So if I give you 7, this has to give you 8. If I give you 9, this has to give you 10. If I give you negative 13, this has to give you negative 12, the next number. If I give you negative 3, this has to give you negative 2. How do you go from here to here? By this time, hopefully you've managed to do it. It's got to take whatever number I give you, x, and it adds 1. Let's see if it works. All the time. Would this always give you the next number? 6 plus 1 is 7. Negative 13, negative 13 plus 1 is negative 12. 53 plus 1 is 54. That would always give you another consecutive number. Now, if you didn't get that one, that's okay. You're still learning. Try the next one, though. How would you go from 3 consecutive numbers would be like 4, 5, 6, 13, 14, 15, negative 13, negative 12, negative 11. How would I get to the next one? Remember, it's got to be based on x. Think about it for a second. Really think about it. Do you understand how to get from here to here? Do one more step. How would I get from 4 to 5 to 6? 7 to 8 to 9. How would I do that? What are you adding? It's going to be addition. What are you adding to that? Well, let's start with 4 and get a 6. 4 plus 1 would give you 5, plus another 1 would give you 6. 4 plus 1 plus 1. Or let's start with 12. 12 plus 1 would give you 13. 12 plus 1 plus 1 would give you 14. So that plus 1 plus 1. We could do that. You could actually do that. No problem. This will always give you 3 consecutive integers, no matter what you start with. I start with 12, you give me 13, and then you give me 14. I start with negative 50, you give me negative 49 and negative 48. Now that looks a little funky. I don't like the plus 1 plus 1. Let's make it x plus 2. Those are 3 consecutive integers, no matter how you start. That's kind of cool. Here's the next part. Once we've assigned our variable to first number, second number, third number, look what we're really doing. We're taking our verbal model and we're just assigning a variable. We're basically practically filling it out. It just gives us a method to do that rather than reading this, trying to come up with this, trying to put it all together and get it right. That's a lot of moving parts there. I don't want a lot of moving parts. I want parts that are understandable. I want parts that are, hey, sum means plus, 3 means 3. Equals means equals. We have a verbal model. Now let's start seeing what consecutive does to relate these numbers to each other. Okay, let's make x for the first number. How do you get to the second number? Add 1. How do you get to the third number? Add 2 to the first number, or add 1 to the second number. Work your way through like that. After you've got this, after you know what your the pieces of your verbal model mean, we can start filling it out. So the first number I know is x. We already know it was a sum. The second number would be x plus 1. Here's the first number, here's the second number. The third number would be x plus 2. Here's the first number, here's the second number, here's the third number, here's the sum of the first number, second number, and third number. Some people choose to put parentheses around it. Those parentheses aren't doing anything. You can put it to show where it comes from, but distributing 1 is not going to change that. That's up to you. Whether you want to put the parentheses or not, I don't care. It doesn't really matter. It just shows the person who's reading it where that stuff is coming from, what that stuff means. And then that sum has to equal negative 123. Now, what's easier? This or this? That one. That's a linear equation. Oh, man, look at that. That's a linear equation, and you know how to solve it. Solving it would be, hey, can I simplify? Well, I can't distribute, but could you combine some like terms? Heck yeah. I got 1x 2x. I got 3x's. In fact, we could circle our common or like terms with their signs, add them together, get 3x. Constants are always like terms. 3x plus 3 equals negative 123. What would you do next? We've simplified. How many variables do you have? So you can't get rid of a smaller variable. Do you know what side the variable's on? Does it have a constant next to it? Get rid of your constant. This side is, the Simon says, it just plays along. The side with your variable tells you what to do. Negative 123 minus 3, that's more negative, more debt, gives you negative 126. Then we divide by 3. If my math is right. And then we're done, right? No, you're not done. Because you got to interpret. This doesn't do anything for you unless you know how to interpret. So that's why we write this junk down, so that we know how to answer the question. You're not going to, I guarantee you, that you're not going to go to your teacher and go, oh, the answer is negative 42, and they're going to give you full credit. That's not going to happen, because you haven't really answered the question. Find the numbers, like all of them. So what are the 3 consecutive numbers? How would you find that? Where would you start? That's what this is for. That's why we write this stuff down. So that you can go, oh, you know what? My first number is negative 42. What's my second number? Well, second number. Add 1 to it. Even on your calculator it'll do it. Negative 42 plus 1, not negative 43, negative 41. And the third number, take your negative 42, add 2 to it, or just continue your pattern. And you know what? It's got to work. Add those 3 numbers together. You'd get negative, 40, 80, 120, 3. You'd get negative 123. It actually works. That is the way that we use verbal models to our advantage. We don't jump right to this. It's very hard to do. We write down what's actually going on. We fill out what's going on with the relationship that's given to us, and then with one variable, relating them to that variable, and then we fill out our verbal model, then we go for it. We're going to try one more, an actual word problem that I just made it up. And so we'll go through that. We'll try the verbal model one more time, and then use that pattern. Use what we're trying to accomplish here for your other word problems. I know they're not exactly the same. Oh, you know what? I almost forgot. What if we changed one word? What if we added a word to this? What if instead of 3 consecutive numbers or 3 consecutive integers, we had 3 consecutive even? Would this change? Well, no. This right here, that would be wrong. It's not going to add to negative 123. But I really just want to focus on what that does to this stuff. So I'm not worried about the stuff here anymore. I'm worried about what 3 consecutive even. 3 even consecutive numbers, either way. We'd still start with our x. But when we say 3 even consecutive numbers or 3 consecutive even numbers, we're not talking about 1, 2, and 3. We're not talking about 4, 5, and 6. We're talking about numbers like 8, 10, 12, or 14, 16, 18, or negative 4, negative 2, 0. We're talking about those sort of numbers. So how would I get from 4 to 6? Have you thought about it? Think about the pattern. I can't just add 1 anymore, can I? Because if I add 1, I'd go from 4 to 5. I want to go from 4 to 6. I want to go from 4 to 6 to 8. 4 plus 2 gives me 6. 4 plus 2 plus 2. We're skipping 1. We're literally skipping 1. So 4 plus 2 gives me 6. 4 plus 2 plus 2. Or 4 plus 4 would give me 8. That's how we go for three consecutive even integers, three even consecutive integers. So whatever number you start with, you'd add 2 to get the next even integer, and you'd add 4 to get the next one after that, the third one. So 12, 14, 16, -4, -2, 0. This is three consecutive even integers. Now here's a brain buster. What if I change this to odd? What about odd? Three odd consecutive integers, or three consecutive odd integers. No change. Because if you start with an odd, you still have to skip the even. Start with 3. Start with 3 and add 2 to it. You get 5. Start with 3 and add 4 to it. You get 7. 3, 5, 7. This works for consecutive even and consecutive odd because you have to skip that number. That's really interesting. So if you're having the sum of 3 consecutive even integers or 3 consecutive odd integers, it's going to be the same setup. Where it changes is what those numbers add to. So that's what would give you the actual equation there. For even numbers, you have to add to an even. So that would be what tells you whether or not you're going to get even numbers out of this. It'd tell you in the problem, but the way that you would set that up is no different between those. So that's kind of interesting. But that's the way you'd set up 3 consecutive even and odd. Hope that makes sense to you. Go back through it again if you can, and think about why we're adding 2 and not just adding 1 to either consecutive even or odd because of that skipping nature of the consecutive even and odd numbers. Okay, so now our next word problem. So let's say that you lose some weight, and you want to be fancy because you're kind of a smarty pants like I am, and you want to tell someone how much weight you lost and refer back to how you started, so your previous weight. So you say, after losing 30 pounds, well, let's make it 40. You feel good about yourself. After losing 40 pounds, you weigh 110 pounds more than 1/4 your previous weight. I told you you're smart, kids. Find your previous weight. It's kind of a weird way to say it, but a lot of word problems are like that. They're kind of weird. So we're trying to say something and make someone else figure it out because we just feel like being that way today. So after losing 40 pounds, so we're going to read it carefully. After losing 40 pounds, what's going on? What's going on with your weight? Did you add weight? Did you drop weight? After losing 40 pounds, you weigh 110 pounds more than, more than is keyword, 1/4 your previous weight. Find the previous weight. So let's talk about the setup here. We're going to make a verbal model. We're going to assign a variable. We're going to relate the variable back to this. Let's read it one more time and try to get a lot of what's going on here. After losing 40 pounds. So after losing, that's one of those reference things. So we're losing pounds from something. This is like a subtracted from or a less than. So I'm going to be subtracting 40, not 40 minus, subtracting 40. You weigh. So that's an equivalent sort of statement. So after doing something, you weigh. After doing something, you equal. So that weigh, that means equals in this problem. This is how these word problems really work in real life. This is a real life situation. I did lose 40 pounds. I don't know if this was my exact thing, I kind of made it up, but if you're going to lose weight, you're going to equal a previous weight times some fraction of your former self. So after losing 40 pounds or subtracting 40, you weigh, this is going to equal 110 pounds more than, okay, that more than, that's a reference word. I'm going to add 110 pounds to something. 1/4 of your, that 1/4 next to something is a multiplication concept. So I'm getting these in my head. 1/4 of my previous weight, I'm going to be multiplying by 1/4 in some time. Find my previous weight. Here's our setup. So our setup says, well, verbal model. We had some sort of previous weight. You can literally write this down. It's worth your time to write down what's going on. So we had a previous weight. What happened? You lost weight. Write it down. How about after that? Well, you equaled a fraction of your former weight. Fraction of former weight, but 110 pounds more than that. This actually works for a verbal model. You have a previous weight. That's what this says. After losing weight, you refer back to your previous weight. So we had this weight. We lost some weight. We lost 40 pounds. We were equal to a fraction of my former weight, but then 110 pounds more than that. We're using those reference words to set up a verbal model. Yeah, your 40 pounds is after your previous weight. For sure, you are subtracting, but it's afterwards. You are 110 pounds more than, but that's a reference word. That's after your fraction. So after whatever comes next, after the quarter of your previous weight. So let's start assigning a variable. Use whatever you want, but what's the one thing up here you don't know? You know how much you lost. You know how much the more than is. You know what the fraction is. What you don't know is what your previous weight is, what the question's asking. Usually I like to tell students, use a variable that makes sense. I wouldn't always use X, Y, and Z. Here I'd probably use W because the W stands for what we're trying to find. So let's write that down. So our previous weight is W. Right there, man, we got some stuff going on. This is great. So we can literally fill out our verbal model just with W here and here. The rest of it, man, it really tells you what to do. So let's read it. So let's take our previous weight. Let's lose some weight. How much weight did you lose? Notice how the after literally told you after your previous weight. That's kind of cool. That's a reference word. So our previous weight, and we subtracted 40 because we lost weight. How much do we weigh now? Well, we're equal to something that we weigh now. The fraction of our previous weight, a quarter of your previous weight, forgot my U there, sorry, of your previous weight, but 110 pounds more than that. Let this sink in, look through it a couple times, make sure that you're understanding where these are coming, how the reference words relate to our verbal model, how we set that up, and then how our variable goes into this. So we had a previous weight, we lost some weight, no problem. W minus 40. How much do we weigh now? Well, this equals what we weigh now. It's a fraction of. Fraction of means you're multiplying a quarter of your previous weight, but 110 pounds more than that. Then you have a linear equation from your verbal model. Hey, simplify it. Try it now. See if you can do that. You got one variable. It's raised to the first power. You got an equal sign. You also have some fractions. No distribution, no combining like terms. There are no like terms here, but you do have a fraction. Can you find your LCD of that fraction, of all your fractions? You might want to write this as W over 1, 40 over 1, W over 4, 110 over 1. You don't have to. It's just good practice to get down your common denominator. Your LCD is, have you found it? It's 4. Multiply every single one of those terms by 4. It's only going to eliminate one fraction because that's all you had, but we would end with, if you want to do this, try this on your own for real. You'd end with multiply everything by 4, 4W minus 160 equals W plus 440. You multiply it by 4, by 4, by 4, and by 4. That's the only thing that simplifies. That's why we get W. Here you get 440, here you get 160, here you get 4W. This is a lot easier to solve. From here, well, can you do it? Can you see that you'd have a smaller variable of W subtracted? Let your variable side drive your problem. Add 160. If my math is right, looks like that. Last step. What's your last step always? You got this? Don't just leave that. Begging you, please don't just leave that. Write a full sentence. This is what word problems are. They give you a full sentence. Give them a full sentence that they have to read, okay? Don't just leave it W or X, even worse. X equals 200. That doesn't say anything. What, $200, 200 minutes, 200 pounds? Well, it's 200 pounds. So write a full sentence to say the previous weight or my previous weight or the previous weight was 200 pounds. That's why we use a variable that refers back to what we're trying to find. Because as soon as you find it, oh, okay, that means that I used to weigh 200 pounds. I lost 40 pounds. I now weigh 160 or whatever it is. That's not true for me, but that's what the word problem says. So anyhow, I hope that makes sense. I hope I've illustrated how you go about reading a word problem and making a verbal model. That's the biggest thing I can get you to do. After that, let that verbal model tell you what your variables are, tell you what your operations are, and then just fill it out. After that, you got something that's reasonable to solve. Hope this helps. I'll see you next time for percents.